Hello guys, Leland Zels here, and today we're continuing chemistry. Investigate the matter that makes a better world. Now, out of the way, get into it. Chapter 3. Changing states of matter. How does matter change its states and go from being a solid to a liquid to gas and back? What happens to an ice cube in hot weather? What happens to a puddle of water in the road on a sunny afternoon after a thunderstorm? Under certain conditions, solids, liquids, and gases can change forms. A solid ice cube can melt into a puddle of liquid water. A puddle of water can evaporate into water vapor, which is gas. A gas. As we learned in the previous chapter, the atoms and molecules of matter are always in motion. Even if we can't see it, these moving parts have mass, even though they are tiny, and therefore have energy. A moving object's energy is called its kinetic energy. The object's speed increases, its kinetic energy also increases. When atoms and molecules are moving fast, they have more kinetic energy than when they are moving slowly. What is temperature? Why is ice cream cold while soup is hot? When you measure temperature, you are measuring the average kinetic energy of the substance atoms and molecules. There are billions of moving atoms and molecules in a substance. Some move quicker and some move slower. When they move and bump into each other, they transfer small amounts of energy. A substance with a higher average kinetic energy have a higher temperature. A substance with a lower average kinetic energy will have a lower temperature. Melting. Solid to liquid. In a solid substance, atoms and molecules are strongly attached to each other and locked in place, giving the solid its shape and volume. But the molecules are still moving and wiggling. When a solid is heated, the molecules increase their motion. Eventually, their motion creates enough kinetic energy to overcome the reactions holding the molecules in place. The molecules are able to move more freely. Then the solid substance changes state and becomes a liquid, in a process called melting. The temperature at which a solid substance melts into a liquid is called its melting point. Different substances have different melting points, depending on the strength of the attractions between its atoms and molecules. A substance with stronger attractions would need more energy in order for its atoms and molecules to overcome their reactions. For example, salt and sugar have two melting points. Sugar's melting point is about 320 degrees Fahrenheit, 160 degrees Celsius. Salt's melting point is much higher at 1,474 degrees Fahrenheit, 801 degrees Celsius. This is because the attraction between the molecules in salt are much stronger than those in sugar. Evaporation. Liquid to gas. Have you ever left a cup of water on the table for several days? might have noticed that amount of water slowly decreases. What is happening? Where does the water go? The water is changing from a liquid into a gas, a process called evaporation. In any liquid, molecules are constantly moving and bumping into each other. The molecules aren't locked in place, but attractions between those molecules hold them close to each other. One molecule in a liquid has enough energy to overcome the forces holding it, but other molecules escapes into the air as a gas. The different liquids evaporate at different rates because the attraction between different types of molecules can be weak or strong. A liquid whose molecules are strongly attracted to each other will evaporate more slowly than a liquid whose molecules are held together by a weaker attraction. The liquid with a stronger attraction between its molecules needs more energy for its molecules to escape and change into a gas. Evaporation happens at the surface of a liquid. So liquids with more surface area experience more evaporation. As the temperature of a liquid increases, molecules move more and increase their kinetic energy. More molecules are able to escape into air as a gas. When a liquid reaches its boiling point, the molecules spread out and form bubbles. Condensation. Gas to liquid. Have you ever seen droplets of water outside of a cold glass? This happens when water vapor in the air changes from a gas into a liquid in a process called condensation. When water vapor molecules in the air touch the cold glass, they transfer some of their energy to the glass and slow down. The molecules no longer have enough energy to overcome their attractions between them. They move together and form water droplets on the glass. The faster molecules join together, the faster rate of concentration. Concentration. Temperature affects the rate of concentration. Cooler temperature reduces the energy in molecules of a gas, slowing the motion. When the motion becomes slow enough, attractions among the molecules pull them together to form a liquid. Freezing. Liquid to solid. Freezing is a process of a liquid changing into a solid. It's the opposite of melting. When a liquid is cooled, its molecules lose energy and slow down. If it is cool enough, the molecules slow down so much that their attractions pull them even closer together and fix them into place to form crystals. The liquid turns into a solid. The temperature at which a liquid turns into a solid is called its freezing point. Different liquids have different freezing points because of the difference into the molecules and attractions. Instead of moving closer together, when they lock into place to form a solid, larger molecules actually move further apart when they form solid ice crystals. In most solids, molecules are close together in the solid. Other changing matter. Other changing matter. Some substances can change directly from a solid to a gas, skipping the liquid state entirely. Have you ever seen dry ice? Dry ice is frozen carbon dioxide, CO2. At room temperature and normal pressure, the frozen CO2 molecules move so fast that they break apart and become a gas rather than a liquid. This change from a solid to a gas is called sublimation. What about going the other way? Under the right conditions, some gases can change directly into a solid, skipping the liquid phase entirely. This process, called deposition, is opposite of sublimation. Sublimation. Have you ever woken up on a cold morning to find a car's windshield covered in frost? Frost is the example of deposition. When there's the right amount of water vapor in the air and the temperature on the ground surface is low enough, the water vapor in the air changes directly into solid frost without becoming liquid water first. And that for today, guys. Hope you guys enjoyed. And I'll see you guys again very, very soon. Later.